Okay, so let's formally define a few key terms that I've been throwing around a little bit willy-nilly, if you like, over the last couple of weeks. Okay, a relation itself, our rules, all the quadratics we've been sketching, they're all relations. A relation by definition is just a set of ordered pairs. So you think about your coordinates, the set of coordinates is just a relation. And so typically our relation can be given to us in three different ways, and we can see them all tied in here together. We can have a table of values, okay, where you've just, your x values are -2, 1, 0, etc., and you generate some y values from it. We can have a graph, and don't forget our graph is just a set of coordinates that we plot, okay, the ordered pairs, or we can have a rule representing that graph or that relation, which is y equals 2x. So any sort of mathematical expression, basically with an equal sign in it, is a relation. Now the ordered pair, remember, the first term in the ordered pair is always the x coordinate. The second term in the ordered pair is always the y coordinate. Okay, that will never change. Now, as we said, the relation is a set of ordered pairs. So the following are just two other relations. If I just sketch one of them there, the set S, okay, is the points 1, 1, 1, 2, the point 3, 4, which might be there, and the point 5, 6, which might be there. So it's just a collection of 4 random points. That's a relation. The point K, or the set K, is another set of random points. It's also a relation. Now, every relation has two key sets of values, okay? The first of these key sets, as it says here, okay, is called the domain. And the domain is the set of all the x values in our relation. So in particular for the set S, if we have a look at our x values, I've got 2 1s, a 3 and a 5. So the domain of S are just the numbers 1, 3 and 5. We don't need to put a repeated value. The range of a relation is the set of all the y values, okay? So the range are the second elements, 1, 2, 4 and 6. That's the range. Range of S. Oh, there's an error there, isn't it? So, I've got 2, 4 and 6 there. Well, that's clearly a mistake there, guys. So the range of S should be, what is the range of S? The y value. So it's 1, 2, 4 and 6. Okay, so there's my range. Domain the x, the range the y. Must. Even x, y, d, then r alphabetically. We have to just have that really clear in our head. All right. Now we spoke already about how some relations can be determined by a rule. So for example, is this formal notation here? What's that say to us here? So if I wanted to write that out in English, curly brackets, the set, it says the set of numbers. Now what sort of numbers are they? Well, they're coordinates x, y. Such that they follow the relationship where y is equal to x plus 1. So in all the coordinates that I'm listing, the y value has to be the x value plus 1. And, comma, given x is an element of 1, 2, 3, 4. So in this case, the x values here are clearly, so we'll just put the domain, is the set of numbers 1, 2, 3, 4. The corresponding range, well, if x is equal to 1, 1 plus 1 is 2. If x is equal to 2, 2 plus 1 is 3. If x is 3, 3 plus 1 is 4. And if x is 4, 4 plus 1 is 5. So there's my range and there's my domain there, okay? And pretty much that's how we do it. The second example here talks about how, same sort of thing. We've got the set of numbers x, y such that y is equal to x plus 1, where x is an element of R. So x is an element of R from that previous exercise means to us that the domain is all real numbers. So if my domain is all real numbers, that means the range is also going to be all real numbers. Okay, so graphically, y is equal to x plus 1, y-intercept of 1. We've got two arrows here to say the graph goes on indefinitely. So my x values, any of these x values are present, aren't they? Or down here. I can use any of those x values, which means if we think about the corresponding y values, the y values I can use are any as well, also are. All right. So it's just getting used to the notation. So the set of numbers x, y, such that, and there's the rule that we get given. So that's how we define a relation. So the key skill for us is being able to determine what the domain and range is of that relation. Let's have a look at some of these other relations. Now, a couple of these are a little bit tricky. In fact, this one here, I'm going to sketch for you because we don't know how to sketch this just yet. So let me sketch the graph. And not that we know it just yet. It's not too bad. That's actually a circle, that graph. A circle with a radius of 1 and a centre at the origin. Okay, so if I look at this graph here, I'll use black to represent my domain. The domain is all the x values. So all the x values for this particular graph go from -1 across to 1. Okay, and in fact, that's what we're told here. So the domain is given by -1 to 1. That's our interval notation. Remembering the square bracket means we include the endpoint. That's the same as saying the set of values x such that -1 is less than or equal to x, which is less than or equal to 1. Both sets of notations are fine. What about the y values? What y values can I have? Well, the maximum value of my function is up there at 1, and I can have all of these y values down there to -1. So it's the same thing in this case, isn't it? So my range of values is from as low as -1 up to as high as +1. Remember, we always put the lowest number first, -1 to 1, never 1 to -1. And if I want to do the range there, it's a set of values, y, such that -1 is less than or equal to y, which is less than or equal to 1. So it's not a great example in the sense that we don't know what a circle looks like yet. The rule for a circle, we'll get to that in the rest of the topic. But the key is, can you look at that graph and go, okay, this is the domain of values, this is the range of the values. Here's another one here that we should be a bit more familiar with. So we've got the graph of 2x plus 3y is equal to 6. So again, I'm going to sketch this graph. Basics. X-intercept means y is equal to 0. If I put y equal to 0, I get 2x is equal to 6, which means x is equal to 3. So I get the point 3, 0. The y-intercept, let's put x equal to 0. So I'll get 3y is equal to 6, which means y will equal to 2. I get the point 0, 2. Now, if I just sketch this graph, and I can here, the point 3, 0 is over here somewhere. The point 0, 2 may be there. And that's the whole graph there. Okay? That's if the domain is R. Now let's have a look at my graph here, and it says I'm only sketching it for the values of x that are greater than or equal to 0, which means greater than or equal to, solid dot. I'm only going to sketch this graph for those x values, which means the x values that are less than 0, well, those y values don't exist. So let's just stop my graph there. I'll write that 2 back in again. Yeah, so that green axis is just showing me that's where my domain is, all right? And so my range are those values from there down to there. All right, so it says where the x values are greater than or equal to 0. So I'm just looking at the right-hand side of my graph. I'm only going to sketch the right-hand side of my graph. And if I only sketch the right-hand side of my graph, it means my x, y values are from 2 down to negative infinity. So now, the domain, which is the x values, written above us, I'm going to use my interval notation, which is from 0 to positive infinity. The range of the values, which is in yellow, okay, the highest value is 2, the lowest value is down here at negative infinity. So I'm going to put from minus infinity up to positive 2. Remember, it's always the lowest number first. All right, so there's a few things in there. It's sketching my graph, sketching my relation over a restricted domain. We're told here just to use the positive x values, which in turn will affect which y values I generate. Let's have a look at the third one. I know you love parabolas. The graph of x squared minus 1. What's that? That's the graph of x squared shifted 1 unit down. So it looks something like that. Yeah. And that point there is at the point 0, negative 1. All right, it says to restrict the graph between negative 1 and positive 2. So what does that mean? So if I put x equal to negative 1, y will equal negative 1 squared minus 1, which is 1 minus 1, which is 0. So on the left-hand side, I'm going to stop my graph there, and that's the point negative 1, 0. And what about the right hand side? It says if x is equal to 2, well then y will equal 2 squared minus 1, which is 4 minus 1, which is 3. So 2 must be, we'll say it's here. Let's just stop my graph about there, say. And that's the point x equal to 2, y is equal to 3. So now, again, I'm going to use green. What's my domain? My domain is here. The domain is the set of x values that I've been told I can have from negative 1 to positive 2, both square brackets, so they're both solid dots. And on my number line, it's those values there. Those x values, they're the ones that I can have. What about the corresponding range? Well, what's the minimum and the maximum y values in that interval? So I go as down as there, and I come up as high as there. So that value there was at negative 1, and this value there was at 3. All right? So the range is from, the lowest value was negative 1, the highest value was 3. And I guess the key thing to note here is that my range isn't necessarily just the y values at the endpoints. That y value there was 0, this y value there was 3. That doesn't necessarily mean that that's a range. It works if it's a straight line. So you've got to have an idea of the graph. So the first thing we're going to do is always sketch a graph, okay? Find the range of this relation here as well with the rule y equals x squared minus 4x plus 5. We'll just slide up a little bit. So again, we've got to have a graph sketch. So this is saying, we've got the full graph. I won't use yellow, I'll keep to my red and blue. So we want to sketch that graph. So we want to know where the minimum value or the maximum value is. So we need a turning point. So we could go with minus b on 2a and work out our turning point. Okay, substitute that in. So let's do that. Minus b, so that would be negative 4 over 2 times 1, which is positive 2. And if I substitute 2 in there, I get 2 squared, which is 4, minus 8, which is negative 4, plus 5, which is 1. So I get the point 21. So I'm thinking my graph should look a little bit like that. Okay, and that is the point 21. Let's check that. I'm going to complete the square on it now. So we get y equals x, I'll do it slowly, halve it and square it is plus 4 minus 4 plus 5. So y is equal to x minus 2 all squared plus 1. So I get a turning point at 2, 1. Good. So there's my graph. There's no restrictions on my domain. So in green, my domain says I can use any x value I want. So I'm just going to put the domain is equal to r. My range, well, what's the lowest y value is from here, and I head up and continue to go indefinitely. So what was the lowest y value? 1. So my range is from 1 to positive infinity. Okay, I could have written, if I wanted to, the range is y such that y is greater than or equal to 1. Okay. Alright, it's starting to get a feel. Domain, x values, range, y values. Alright. Sometimes, a bit like that previous example, we're not told specifically what the domain is. Okay. And so what we say then is, we're saying that the maximal domain is implied. So if we're not told what the domain is, we assume it's the biggest possible domain allowable. Okay. So if you think about the graph of y equals x squared, y equals x squared is, y equals x squared is just a parabola, and we know that we can put in any x value. So the implied domain for that is R. Again, that little circle that pops up that we haven't covered just yet. So that's a circle centered at the origin and has a radius of 1. So whilst it's a little bit new for us at the moment, the implied domain there is between -1 and 1. Okay, so again, look, in reality, I've got to update these notes, boys, because we've changed the order a little bit. So we haven't covered circles yet. We're going to do that a little bit later. Okay, so key skills. A relation is a set of ordered pairs, and we can have that set of ordered pairs as either coordinates, a graph, a table, and then all of those relations have 2 key sets. One of them is the domain of the function, the domain of the relation, and the other is the range of the relation. Okay, the domain, all the x values, the range, all the y values. Crucial things to remember.